In this presentation, I'll be working out some problems involving arithmetic sequences and series. Well, what I've got is a rock and I drop it, and in the first second it travels 5 meters. In the second second it travels 15 meters. In the third second it travels 25 meters, and in the fourth second it travels 35 meters. The distances the rock falls each second, well, those distances form the terms of an arithmetic sequence. I need to work out how far the rock falls during the 10th second. Well, I know that n equals 10, because we are talking about the 10th term, the value of that 10th term. I know that a equals 5, the value of the first term in that arithmetic sequence. And d, well, that's 25 minus 15, 25 minus the value of the term immediately preceding it, and 25 minus 15 is 10. So d is the common difference, and that's 10. That's the formula I'll be using, and I'll be substituting those values that I just spoke about into that formula. So the value of that 10th term is equal to 5, that's a, plus n minus 1 or 10 minus 1 times d, which is 10, and I end up with 95 meters. So that's how far the rock falls during the 10th second of its motion. Now, the distance the rock falls during the nth second is described as Tn is equal to Wn plus z, where W and Z are constants and d is the common difference. I need to find the values of W and Z. Well, I know that A equals 5 and D equals 10, and again I use this formula. I substitute those values into the formula, and I end up with 5 plus 10n minus 10, and I end up with 10n minus 5, but that can be rearranged as 10n plus minus 5. And comparing that to the expression in the question, W equals 10 and Z equals minus 5. Well, this next question is much more challenging. The rock falls for 50 seconds. How far does it fall during the last 10 seconds of its motion? Well, this is the formula I'm going to use, a formula for the arithmetic series. And it's the motion during the last 10 seconds. So what I need to work out is the value of T41. That'll be how far the rock falls during the 41st second. I need to add that to how far it falls during the 42nd second, then add that to how far it falls during the 43rd second, and so forth. And finally, I'll have to add how far it falls during the 50th second. In that arithmetic series, well, what I've got is 10 numbers, n equals 10. I've got 10 terms that I'm adding. And for that particular sequence, the first term is T41, and that last term is the value of T50. So I need to work out T41, how far the rock falls during the 41st second. And I go back to that original progression or series where A equals 5 and D equals 10. I substitute those values into the formula. Oh, and of course, n equals 41. And when I substitute those values into the formula, I get T41 is equal to 405. I use the same formula to work out the value of the last term, T50. Same as before, except n equals 50. And I finally get 495 meters. That's how far it falls during the last second of its motion. Now I substitute those values into that original formula there, S10, where n equals 10, and this time A equals 405 and L equals 495. If you work that out, you get 4,500 meters, and that's how far that rock falls during the last 10 seconds of its motion. But there is another way of solving this problem. Now, if I add up every single term in this arithmetic sequence, I'll work out the total distance that the rock falls for 50 seconds. But I only need to work out how far it falls in the last 10 seconds. So it's those terms, the last 10 terms. The sum of the last 10 terms is how far the rock travels in the last 10 seconds of its motion. That's what I'm really after. So to get the answer, I'm going to get the sum of all 50 terms and minus from that the sum of the first 40 terms. And yes, that'll give me the answer. Now A equals 5, D equals 10, and that's the formula for the sum that I'm going to use. I'm going to work out the sum of the 50 terms, all the terms, where n equals 50, and I end up getting 12,500. That's the sum of all 50 terms. That's the total distance the rock falls. Now the sum of the first 40 terms, where n equals 40, well, that's what the formula looks like when you substitute in those values for A equals 5 and D equals 10 and n equals 40. I end up with S40 equals 8,000, and I minus those numbers, 12,500 minus 8,000, and I get the same answer as before, 4,500 meters. So there are two ways of working this out, but either way, you get the same answer. Thanks very much for viewing.